This question looks scary, and maybe for some of you, the big numbers aren't really easy to think about, or just exponential equations in general you're not really sure about, but we do have a formula that we can memorize to help us there. But ultimately, what I see when I look at this question is, even if I'm a little unsure, I can always plug points into equations, my favorite strategy. Now, it's very obvious that I have equations, right? Like, that's what the answer choices are. It might not be as obvious that I have points, but this is a skill, is being able to see, okay, I've got equations. Can I come up with some points to put into those equations and test them out? And so the most obvious is going to be something like this. When they say that the initial value is, in this case, $36,100, that's a point. That is the point 0 for my t, 36,100 for my y, or a of t in this case. So initial values we have to remember are basically y-intercepts, and so the x-coordinate is 0. So if we plugged in 0 for all of the t values, we would expect to get the 36,100 out. If we did that in choice A, we would definitely get that, because just to kind of shortcut it a little bit, if we made this a 0, 1.05 to the 0 is just 1. So that's going to happen with all these answer choices, is whatever's in parentheses, if we raise it to the 0 power, it just becomes a 1. That's a fundamental idea in math, is anything raised to the 0 power is 1. So that just means that the value that we would get out is going to be just whatever the first number is, because that number times 1 is just that number. So we can see very quickly then that choices B and C are not going to give us the 36,100 that we're looking for. And if you understand how exponential equations are built, that should have been obvious as well. The formula that I use to think about them is a version of the open formula that we use when we're dealing with regular percentages. And that's because what is an exponential equation? It's really just a percentage that we take repeatedly over time. And so it's the same basic format. What we would want is 0, or O I should say, O times 1 plus or minus P to the T is equal to the N, the new value. So the O stands for the original value. So in that spot is supposed to go our initial value. In this case, they just say the initial value is 36,100. So we know that we expect that number in that spot. So you've got two ways of kind of getting there. Then you have to think, well, what's happening? Why would it be 1.05, or actually let's highlight differently. Why would it be 1.05 versus 0.05? And it does have to do a little bit with the story. They're saying it's earning interest, so it's increasing. And we can see that we have a higher number at the end of the run, at the end of the 13 years. So if you understand how the open formula works, once again, we can use that to our advantage. If we had an increase in the parentheses, we would have this 1 plus, because the plus means an increase. And then the P represents the percentage as a decimal. So in this case, they don't really tell us, but now we can figure out that they're saying that this is 5% interest. I don't think they actually say that here, but the equation is telling us that, meaning that our 36,100 is going to be multiplied by 1.05, and that'll be raised to some power to give us the new value after however many years. So we need it to be the 1.05 to be an increase, so that gets us to choice A. Now, if that's a lot to memorize or it sounds confusing, then again, we have the plug points into equations strategy here that we can use, because at the end of this question, they are giving us another point. They're telling us the value for t is 13, and then the value for a of t is $68,071.93. So we can plug that point into the equation. So if you do, in this case, 36,100 times 1.05 to the 13, 36,001, or let's do 1.05 to the 13, I'm just using my regular calculator, is 1.886. And then if I multiply that by 36,100, I get $68,071.93, exactly what I was looking for. Now, of course, we would need to check choice D to make sure that that also kind of doesn't give us the same value, but it's very obvious it's not going to. 36,100 times 0.05 to the 13th. This is going to be a very small number. Again, plugging it in, 0.05 to the 13th. So my calculator can't even really handle it. It's 1.22 but times 10 to the minus 17. That's a very, very small number. And even if I multiply that by 36,100, I'm still going to have a small number. It gives me 4.4 times 10 to the minus 13. So basically you have zero money left in that particular account. So it's definitely not D. This is the kind of thing that I would say is very easy if we memorize the open formula and understand how exponentials are built. But I do want to stress that we have this backup of plug points into equations. And there may be other situations where that is better because maybe it doesn't follow a kind of more standard equation like a y equals mx plus b or like an open formula. And so if we can read a story and learn how to pull points out of it, we can test those points in equations, which is much easier than trying to conceptually think about what's happening in the story and build the equation from scratch. I would much rather test what I'm given rather than kind of build something out of thin air. It's always better to kind of guess and check these. So remember to look for points when the question gives you equations.